T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, and liftoff of Starlink 634. Go Starlink, go Falcon.
Vehicles pitching downrange.
Stage 1 propulsion is nominal.
Nominal power and telemetry.
Falcon and Starlink are supersonic. Max Q.
Main engine cutoff.
Stage separation confirmed.
And back ignition.
Fairing separation confirmed.
Stage 1 landing leg deploy. Stage 1 landing confirmed.
Good morning, y'all. We are standing by for a... Wait a second. Can we get some rocket views on the stream? Do we have any views of a rocket here, please? Stand by, folks. Let's check some rocket views if we could. There we go. Now we've got ourselves a rocket show. Folks, you've joined the official live stream for Firefly Aerospace. It's Flight 4, Fly the Lightning this morning. We are doing a dedicated commercial launch for Lockheed Martin, and really quickly, NASA Spaceflight is providing live stream services for Firefly Aerospace for today's stream. I'm John Galloway with NSF. With me today this morning, I've got a friend who knows a lot more about rockets than me, Miles Gray. Dr. Miles Gray, how you doing?
I'm doing pretty well. How are you?
I'm pretty good. How did we luck out and get you on the stream this morning? You're busy with the rocket.
Yeah, so I'm the chief engineer for our other rocket, MLV.
MLV.
And so I'm not working on Alpha anymore, but I came to Firefly 5 years ago and worked a lot on Alpha, so I have kind of a lot of information about Alpha, but I'm not critical for the launch today.
Gotcha. So you're not on console and mission control, so you get to hang out with us?
Yeah, exactly.
All right. So Miles will be providing us some information about Alpha because he's worked on it himself. And we are coming up now less than an hour for launch. Appreciate everybody joining us today. You may be watching in multiple different places. You may be over on Firefly's official YouTube channel. If you are, make sure you follow along there. Ring the bell or whatever you're supposed to do. You may also be watching it on NSF stream. You may be watching it on social media X as well. Wherever you're watching, thank you so much for joining us. This morning, we have just a 16-minute window remaining, I think, right? I think we were down to 16 minutes starting at, where was our T0? We're talking about Vandenberg here. All right. I believe our T0 is coming up in less than an hour, coming up on 56 minutes now. There we go. And we're looking at Slick 2 over here at Vandenberg. There's the zoom in coming down the coast. Anything informational about here at Slick 2?
So Slick 2, it's our pad. We're kind of near the beach, a little bit more inland than some of the other pads. Just down the way is Shark Beach.
Shark Beach. Are there actually sharks there?
There is a bunch of sharks there. It is the largest breeding and feeding site for great whites.
Largest breeding and breeding site for great whites.
Not a lot of swimming.
Not a lot of swimming there. So more focusing on the rocket, working on the rocket than going down and hanging out at the beach.
Yes.
All right. Hey, folks, some other housekeeping real quick. Today, at the request of the customer, we are going to remove the live views of the vehicle after SECO 1. So we'll tell you a little bit more about SECO 1 and the mission operations that are going to happen. But intentionally, those feeds will be cut after SECO 1. It's got a long coast phase in there. We're not going to stay around for the entire coast phase. Just want y'all to know if we turn off those feeds, that is an intentional thing. So we got past the Shark Beach part, I guess. Since we're doing the live stream here, also, if you've got questions for us, you can tag us in chat on whatever channel you're watching at Firefly Space if you're on Firefly's YouTube channel, and at NASA Spaceflight if you're on NASA Spaceflight's YouTube channel. So we've been going a little while here, and the teams have already been working on the rocket this morning, haven't they?
That's right. You can see on the camera there's not actually anybody out there now because we already went through pad clear. That happened at T-minus 4 hours and 30 minutes. So everybody's gone. That group is called Red Team. They kind of, their whole job is pulling off all the RBF tags. They're turning the last valves they need to get propellant on board. They're basically just kind of locking up as they retreat from the pad.
Gotcha.
So that happened at 4 hours and 30 minutes. We started the rocket kind of comes alive. From my perspective, at least, I'm kind of a fluids guy, but
it starts to breathe.
Yeah, it starts to breathe at T-minus 6 hours. We start loading helium. So our system has like a circulation loop rather than just filling helium into the LOX tanks.
Right.
So we start at T-minus 6 hours. We start chilling and filling. So we're increasing pressure as we're going down in temperature. And then an hour later, we started fuel load. So we can put fuel on when people are still out there. We just can't put out fuel and oxidizer.
At the same time.
Yeah, you can't allow those to, because it's risky if they mix. And,
right. That's sort of how the rocket works in the first place.
Exactly.
Yeah.
So we loaded basically all the fuel at T-minus 5 hours. So it's completely full of fuel. And then immediately after pad clear, we can start loading LOX. So we also have almost all of the LOX on board that we're going to have.
Gotcha.
You can actually see on the stream there, there's this kind of plume of gas that's coming out. That is the first stage from this view. That's the first stage LOX tank. It's just boiling off. So we fill saturated LOX as opposed to subcooled LOX. So
right.
Some rocket companies will fill, they pre-chill the LOX, so it's actually colder than its boiling point. So the whole time it's on the pad, it's slowly warming up.
Right.
We do the opposite. We actually fill, it's above its boiling point, and it's slowly boiling down. It's getting colder and colder as it boils.
Wait, it gets colder as it boils?
Yeah, thermodynamics.
Thermodynamics. Outside the scope of this stream,
yes.
We'll need like a 2-hour stream to explain thermodynamics.
The magic of thermodynamics. It's getting colder the whole time. That also means that it's boiling off, so it's losing mass. So that fog that you're seeing, is it just, barfing out mass the whole time.
Barfing out mass. We brought the rocket science onto the stream here, folks, this morning. But it's intentional is the important thing.
Yeah, that's it. And you can see there should be, it's a little hard to see in this, but there's actually 2 more plumes above that. That's the second stage. So the first stage is just one big one, and then there's 2 that are on opposite sides for the second stage.
Gotcha.
So that it's non-propulsive.
Non-propulsive. That would be a problem if you have venting coming out one side of the rocket and it's trying to coast. That may impart some
exactly.
impulse
so you have
onto
to
the
be
rocket.
Constantly correcting in your coast period, and you don't want to do that. You're just using RCS gas. You don't
want to do that. All right, good deal. Let's see here. Folks, a quick correction, or not a correction, on the T0 here. The T0 is actually set for 9:32 and 30 seconds this morning, about 52 and a half minutes, 51 minutes away right now. We had a late-breaking change in the T0, so I was ready to tell you at the very beginning and wanted to make sure I said the right thing. Where are we coming up next? We've got some payload, I think, information here. Here we go. Yeah, so this payload is actually delivering faster on-orbit capabilities for U.S. warfighters. Remember, it's a commercial payload for Lockheed Martin. It's a national security technology demonstration. What does that mean? Oh, we've got some information about it, right?
We do.
We have a little bit of information put out on social media. You may have seen that we're talking about electronically steerable antennas, I think, right?
Exactly.
The electronically steerable. You know something? The best people to tell us about the payload are the people who built it. So let's get some information directly from Lockheed Martin here, if we could.
Hi, I'm Paul Pelly, Senior Director of Global Security at Lockheed Martin Space. I'm excited for today's Firefly launch, and I want to share a little context about the unique payload we're launching into orbit. It really is all about responding to our customers' need for increased speed to mission. Historically, on-orbit sensors can take months to be fully calibrated and ready to perform their missions after initial power on. Using the innovation of Lockheed Martin's Ignite team, we've self-funded and developed a unique wideband electronically steerable antenna, or ESA, for this demonstration. Our ESA is a novel scalable design using highly reliable commercial parts and is mass producible. Once we're on orbit and our satellite has completed checkout, Lockheed Martin expects to calibrate this new ESA sensor in a fraction of the time it takes to operationalize traditional on-orbit sensors. Essentially, we're going to show how we can put on-orbit capability into the hands of our warfighters faster. This demonstration is an example of Lockheed Martin's significant investment in bringing scalable ESA technology to orbit. ESAs are powerful and incredibly flexible, have no moving parts, and can generate multiple energy beams simultaneously. We believe this technology is critical to future remote sensing architectures. Lockheed Martin is excited to show what this ESA can do on orbit. Go for launch.
I like it. Go fly the Lightning. And we are now less than 15 minutes away. The time just evaporates as we get this close in the count. Important things just happened while we were looking at that video. I think we're into the terminal. You know what it is.
Yeah, so we should be in what's called terminal count now. At about T-minus 15 minutes, we hand over control to our ground system.
Right.
So the operators that have been clicking buttons all day today, they basically are not going to click anything for the next 15 minutes.
They just run this. I say run the script.
Yeah,
but,
they run this auto sequence. The auto sequence is very complicated, and it's calling other auto sequences. It's performing actions. Right now, it's basically timed that 15 minutes on the engine chill. So you can see that little fog that's coming out of the bottom of the engines there.
Yeah, from the engine cam.
Yes, that is LOX that is blowing through these first stage LOX pumps. So we time this. It basically takes 15 minutes to chill in those pumps, so that's when terminal count starts.
Hey, by the way, on the engine cams real quick, when we were we have a lot of cameras for the broadcast, and we were choosing cameras, we saw the engine cam, we're like, we have to have the engine cam. And some folks were like, nobody wants the engine cam? No, that doesn't show much. Chat, do you want to see the engine cam? Let us know in the chat if you are interested in engine bell shot. There we go, thank you. During rocket operations. So you can see the vapors there, like Miles said.
You can also see that flicker of it's kind of changing color. That's jumping liquid or gas. So as we're running through that line, that bleed line, there's heat going to that. So most of it is gas, but as it gets more and more chilled in, you'll see that it'll be more and more liquid.
It gets dark, like it's a darker white line, I guess, right?
Denser, yeah.
Yeah, denser, that's the right word. Nice. All right, so we're continuing to go forward here. 12 minutes and 40 seconds around that. What do we have coming up next? Some ground side preparations, I think.
Yeah, so we have the kind of last setting for TTEB and spin start. Both of those systems are kind of inherently dangerous to both the rocket and the pad. So we wait for a very long time before we do this.
Right.
We're single seat to the vehicle now. So we've opened up all the valves except for the last isolation that is going to be the thing that actually sends TTEB to the vehicle or
to light the engines
or does the spin start. Yes, to start the engines. We should, I think, here see also there's some TBC wiggles that are going to happen on the first stage engines.
We may not be able to catch them, but we'll see if we do. I saw them this morning.
Yeah, basically what that is, we bleed in a long time ago. We did some bleed ins, and then there's a last check in terminal count to verify that everything's hunky dory. That what they're doing is they're moving them, and they're not actually looking to just see that they move. They're seeing that they move smoothly. Because the way that these TBC actuators work, they have something called a servo valve in them that if it ingests any gas, it'll kind of judder along.
It won't move smoothly.
Right. And that really affects your control system. You don't want to have that happening, so we need to make sure that we have a good bleed on the TBC.
Gotcha. So that's when they move back and forth. But we didn't mention the TVC on this rocket's really interesting. Sometimes the engines can wiggle, waggle, whatever term you want, in more than one direction. They can vector in more than one direction.
Right. So the Reaver engines only have a single axis thrust vector control.
They just move in one direction.
Each engine only has one axis, so you have pitch engines and yaw engines, which is kind of a common scheme in like Russian and Ukrainian rockets, but not so common in American rockets.
Okay.
But it's simpler. There's fewer parts. You don't have as many things to deal with. You don't have as many things that can break.
Yep.
So that's kind of typical Firefly direction.
Like each engine just hinges on one axis, and I imagine you have 4 engines. You probably have 2 pitch engines and 2 yaw engines?
Yep. And then they can all move together to roll the rocket.
Gotcha. And they're probably at 90 degrees from each other, like the pitches and the yaws, and they... Makes sense. There's the engines again. I didn't see the TVC wiggle, but some of you should probably check social if you're interested in TVC wiggles at some point. We'll see if we can get some of that out there for you. Coming up next is T-minus 10 minutes, just about 10 and a half right now. What do we have coming up after that?
So at T-minus 8, we're going to do the fuel prepress. So for most of the day, there's been a small amount of blanket pressure on the fuel tank, just to make it easier to control. We don't have to worry about ingesting water or anything into the tank. So there's a little bit of pressure.
Right.
We're going to go up all the way to flight pressure on that tank at T-minus 8 minutes. So that takes maybe 3 minutes to do that. So we do it fairly slowly, just because we don't need to do it fast.
Why do you wait so long? Like, why don't you put it to full pressure before, like, earlier?
And you'll kind of see this in all these things, that there's a lot of stuff that's happening in these last 15 minutes, and it's all set up in time so that we don't put cycles on components that we don't want to cycle.
Ah.
So everything has some qualified number of cycles, and we want to make sure that we don't sort of erroneously put a cycle on something when we didn't need to, because if we're going to find a problem with something else that is, more critical, then we don't want to accidentally damage something.
Gotcha.
Just by using it.
So every time you send it up to flight pressures, I guess, right? You use up one of those cycles.
Yeah, it's called a lolly.
A lolly?
Yeah.
What?
We're putting a lolly on the tank.
Putting a lolly on the tank, right? Burning one of the cycles that you have there, and you don't want to do that too many times. You want to make sure everything else is good to go before you put a lolly on.
Yeah,
I don't know how to use that as a verb.
That's how you do it. Before you put a lolly on the tank, you don't want to do that. So the fuel tank actually has it'll get pressed up first. The LOX tank doesn't get pressed up until T-minus 3 minutes. And part of that is that you can see where we're blowing that LOX out.
Yeah.
When we press that LOX tank up, you'll see this will pick up a lot. So you're going to be using more LOX through that bleed system, and you don't want to use too much LOX. So we wait until the very end.
Gotcha. And then after that, we're going to get into, after the fuel prepress, I guess, begins. It takes some time to do that, right? We might get into stage 2, I think, huh?
Yeah, and I don't think we're going to be able to see this. I don't think we have a camera in the vehicle on this feed. We actually do have a camera in the vehicle that operators can see. And they're going to do the same thing as we did on the first stage, where we're going to look at the engine and see it move. It moves a lot less than the first stage engines, because it's kind of
in the interstage.
It's in the interstage, so it doesn't have a lot of room.
So not visible from the outside of the rocket.
Yeah, but it'll do a little wiggle, and we'll just verify everything's good there, and just that's our last check of that system.
Gotcha. We got a big bunch of fog there all of a sudden, it looks like. All right, folks, we get this question a lot of the time, where you might be able to see today's launch from. We have a very interesting trajectory happening, but let's see in just a second if we can't give you a visibility map that shows where you might be able to see it. There we go. So there's Slick 2 over there at Vandenberg. That's the spreading T+, 30 seconds, 40 seconds. Down there in Los Angeles, you might look out over the ocean. Not sure if the clouds are going to be a problem out there for you. Up to San Francisco, you might be able to look south. Again, fighting the weather here. Not sure. If you can see it from Las Vegas, let us know on social media, please. Phoenix, good luck. But look out there today. If you're able to walk outside, you might get a chance to view the rocket heading out to its trajectory, carrying Flight 4, the Fly the Lightning mission, actually, for Lockheed Martin. Where are we at now? T-minus 7-ish minutes, I think? Yeah, there we go. Just crossed under T-minus. It actually says stage 2 TVC wiggles on the screen. Nice. I like it. Also coming up here in 40 seconds or so, transitioning to internal power.
Right. So all day today, we've kept the batteries at charge, but we're not actually drawing power from the batteries on the vehicle. So we're just letting them sit there. They're doing their own thing, and we're feeding power to the vehicle from the ground. And that we're now switching over. We're switching over now to have the power draw from the vehicle and feed to directly.
So you're still like topping it off, but the vehicle is providing the power.
We're still keeping it charged because we don't want to have to
drain the battery.
That is
carry more batteries.
To carry an extra 6 minutes of power, but
yeah. Makes sense. So moving to internal power is an important part of the step here that should be coming up in just a few seconds. We're going to see some visual motion here. After that, we'll get the collar arms open.
Yeah, at the top of the rocket on the strong back, you can see up.
There you go. That's the view.
So those are going to open, and we keep them closed normally. There you go.
There you go. Good timing.
And then the strong back will retract a little bit after that once we're sure that the collar arms have done what they're supposed to do.
They are definitely retracting. It's almost like this is a carefully choreographed ballet of rocket machinery.
Almost. So those pull away. The strong back's going to retract. We don't do that early because the wind allowable on the rocket is much higher if you have that attached.
Ah, look at that. There it goes. And it's got a little slack in the umbilicals. They're umbilicals, right?
Yep, those are umbilicals. We call them catenaries for some reason. Catenaries, the curve of when you're under gravity, and somehow that just stuck.
Well, they're curving a little bit less under gravity now.
Term would be umbilicals.
All right.
You can see that there's these. It's getting away, but it's not actually. Nothing's tight yet. There is some maybe elastic pieces there.
Just a little, not droop to it.
Anything that's hard has a droop to it because the rocket is actually what pulls it off. The movement of the rocket will pull those cuties off.
So it's not something that pushes out or anything. Like the rocket starts to move and it pulls those cuties out.
There's a wire rope that's going to yank on those cuties and it'll open a latch and things will fall off.
Gotcha. Folks, it's 4 minutes and 30 seconds now. We're still marching towards the T0. I haven't seen any holds in the count or anything like that.
No,
we got that
going good.
super smooth go, no-go poll. We do have one last go, no-go poll that's coming up here around T-minus 2 minutes. It may happen a little early. It may happen a little late. So if we're talking and we jump to that, we want to listen in on that final commit. But a lot of things still happening here. We saw the strongback retract. Look, this camera is even different now because the strongback has retracted. You can even see the ice on the side of it.
It's also, you can see it's one side that you get ice on.
Yep.
It's the same temperature, but there's just more airflow going over the other side.
I wonder if that's the windward side or the leeward side.
It's leeward side.
It's the leeward side where the wind is not blowing that freezes the ice. No kidding. And we're going to be getting into things like fuel bleed and that sort of stuff here, but now under 4 minutes from launch as we watch all sort of different views of the rockets. We do expect to have some pad audio coming up here as well. And for the last probably 90 seconds or so, we're just going to let you all soak in the sounds of the pad and hopefully the ignition and liftoff here. 3.5 minutes still counting down. This is go time, isn't it, Miles?
Yeah, yes. This is the nail biter.
How you doing? Can we put a heart rate monitor on you and
honestly,
graph it on the screen?
I'm climbing up the walls that I don't have plots in front of me.
Normally you have screens to look at, and here you don't have screens to look at.
It's hard.
All right, well, the count continues to happen as we begin to cross over the T-minus 3 minute mark. Here again, this is Firefly's Flight 4. It is Fly the Lightning, a commercial mission for Lockheed Martin. About 1 minute away from that final commit to launch, where the launch conductor is going to ask for the go, no-go, so we are definitely going to listen in on that. We got some clouds up there today. I see a little bit of blue, but hopefully we get some visibility of the rocket as it goes. Can it go through the clouds?
Oh, yeah. There's a certain amount of thickness of clouds that you can't get through because of both ice buildup and tribo-electrification.
I was hoping we would get a chance to say that.
You'll charge the rocket up, which is bad for the avionics, but there's some amount of clouds you can get through, no trouble.
Good deal. So, folks, let's go ahead and do this. Let's listen in on the final commit. We'll do our best to be quiet.
Final commit for launch. Chief Engineer. Alpha is ready. Send it. Launch Director.
LD's go for Flight 4.
Rock. We are go for launch.
Folks, T-minus 2 minutes. That's what you wanted to hear. The final commit to launch. 3 goes from the Chief Engineer, the Launch Director, and the Range Operations Coordinator. Quick reminder for folks watching, we do expect that we'll have onboard video, hopefully, but we will be intentionally cutting that feed after SECO 1 at the request of the customer. We're coming up on 90 seconds, a minute and a half for Firefly's Flight 4.
Seconds.
You know something? I think we're going to listen into the pad and the command net, and we'll just say, go Alpha Flight 4, fly the Lightning.
Seconds. $45 seconds. Acknowledging alarms. 30 seconds.
CD1 vehicle has transitioned to autonomous mode.
20 seconds.
Stage 1 TVC motion looks nominal.
15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I see the clouds.
Vehicle supersonic.
Vehicle supersonic now.
It's you.
So we're past max speed now as well.
It's awesome, great.
See the plumes start to expand there. That's the Lightning engine, isn't it, there?
Yep. That's Miko.
Eco.
Stage separation.
Look at that.
Stage 2 ignition. Power looks nominal.
Yeah. Nice. You actually see the booster there. The second stage continuing on.
Yeah, we should see the fairings in just a second here. Bada boom.
That was the payload fairing. Separation.
Separation.
Just let them say it. Look at that view. Now this is a longer burn now, right?
Yeah, much longer.
Like the Firefly logo there. Must be one of the long-range trackers, getting it through the clouds on occasion. It's easier to see through the clouds from up here.
Yeah, yes, it is. And we're going to start seeing, you can see a little bit, that second stage engine nozzle extension is going to start glowing, which is normal.
Okay.
It's radiatively cooled because there's nothing around, right? It's vacuum.
Because the black body radiation coming off, it's starting to glow red.
And so you have to deliberately make sure that nozzle extension has high emissivity, so it'll cool itself naturally.
It'll radiate off a lot of that energy.
Mm-hmm.
T plus 5 minutes, everything is nominal.
Sun in the background there.
Pad B. T plus 6 minutes.
Those onboard cameras keep sending us pixels. We'll take them.
I think we should have it all the way through to Seco. It's pretty westward, so.
Yeah. And a quick reminder here, folks, at Seco 1, we do intentionally plan to cut the feeds from the vehicle at the request of the customer. We'll still be here with updates for you.
T plus 7 minutes.
See a little piece of ice on occasion go past?
Mm-hmm. Not all of it melts off. There's always a little bit that hangs out.
Stuck in little nooks and crannies. And
if you watch the last video as well, same thing happened.
Copy.
Seco. Nominal transfer orbit achieved.
There you have it. We got a transfer orbit achieved. It sounded like the call out there was.
That's pretty good.
That's pretty good.
Pretty happy about that.
That's pretty good, he says. Folks, you saw it. Flight 4 flew the Lightning. I guess you would say flew the Lightning.
Flew the Lightning.
We had liftoff from Vandenberg. Here's back at Texas. I think that second camera we have there, some clapping going on.
Expected LOS
but
at
let's talk about what's next.
I'm
going to be quiet every time I hear mission control. We're still coasting. We've made it to Seco 1.
We're coasting.
Mission's not done.
We're in orbit now. So we're in an elliptical orbit right now. And then if you think about kind of we enter that at the lowest point in the orbit.
Right.
So now we have to coast along to the highest point in that
orbit. We're
orbit.
kind of coasting uphill right now, actually.
Yes. And so once we get to that furthest point, then we'll light the engine again, and that'll circularize us. So then we'll be in a big circular orbit, and so that's the useful orbit.
Gotcha. So what happened is we took a lot of chemical energy that was stored in the fuel of the rocket. We turned that into kinetic energy, and we pushed the rocket forward, and now that's sort of coasting uphill, and it's turning it back into potential energy.
Yes.
Height above the surface of the Earth.
Physics lessons
in
the live stream.
The velocity is decreasing now as it increases its altitude.
Yep.
And the total energy, it's a little bit of atmospheric drag maybe way up there, but the total energy is about the same. It's just trading height for speed right now.
Right. And so then at the top, that burn is super short. It's like I joke that it's a cough. Like it just, and it stops. So it comes up to power, drops almost instantly. It's like it's a little triangle of thrust.
Just real quick.
And then we'll reorient the rocket, the stage with the RCS, so that we have these little nitrogen cold gas thrusters.
Right.
They're also active during the burns because you have to have roll control.
So keep it on its
because you only
trajectory.
have one engine, so there's nothing to keep you from spinning.
Ah, right.
And so those will reorient the stage, and then we'll deploy that payload, and then mission complete.
Good deal. So, folks, a reminder, the mission is still ongoing. We are in this coast phase, about 45 minutes long. We won't be on the entire time here. But for the most recent updates, make sure you head over to Firefly's social media channels. Over on X, there it is, at Firefly_space. And that is going to be the best, fastest way to get updates on the ongoing mission for Flight 04 here. Do it right now. If you do, let's get a clickable link into chat. Maybe in chat, tell us you went over there and followed Firefly_space on X. Now,